Hello students, I am Subhashish. In our previous session, we have learnt about the quadratic equation formation and factorizing quadratic polynomials by splitting the middle terms. In this session, we will learn about finding the solution of quadratic equation and nature of the roots. Learning outcomes. After the completion of this lesson, you will be able to understand the concept of quadratic equations and their roots. Apply factorization techniques to solve quadratic equations. Determine the nature of roots based on the discriminant of the quadratic equation. Keywords from this lesson are quadratic equation, factorization, nature of roots, discriminant, and distinct. In general, a real number alpha is called the root of the quadratic equation. Ax square plus bx plus c equal to 0, where a is not equal to 0. If a alpha square plus b alpha plus c equal to 0, we also say that x equal to alpha is a solution of the quadratic equation or that alpha satisfies the quadratic equation. Note, the zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c equal to 0 are the same. A quadratic polynomial can have at most two zeros. So, any quadratic equation can have at most two roots. For example, consider the quadratic equation 5x square minus 4x minus 1 equal to 0. Substitute x equal to 1 on the LHS of the equation. 5 into 1 square minus 4 into 1 minus 1, that is equal to 0. Five into 1 is equal to 5 minus 4 into 1 is 4 minus 1, that is equal to 0. Five minus 4 and minus 1 gives rise to minus 5. 5 minus 5 is equal to 0. So, now LHS equal to RHS of the equation. Hence, 1 is a root of the quadratic equation 5x square minus 4x minus 1 equal to 0. We can use this knowledge for finding the roots of a quadratic equation. Let us see some examples. Example: find the roots of a equation 4x square minus 8x plus 3 equal to 0 by factorization. Solution: in factorization method, we split the middle term. First, we multiply the coefficient of x square, that is 4, with constant, that is 3. We get 4 into 3, that is equal to 12. Now find the factors of 12. When we add 4 plus 3, we get 7, which is not equal to 8. From the factors, we select 6 multiplied by 2 because when we add 6 and 2, we get the middle term, that is 8. After splitting, now from the equation, take the common terms. Those are 2x from 4x square and 2x, and 3 from 6x and 3. Now write down the terms. Then after equate 2x minus 3 and 2x minus 1 with 0. When minus 3 moves to right hand side, it will become plus 3. When 2 multiplied by x goes to right hand side, it will become x equal to 3 by 2. When minus 1 on the left hand side moves to right hand side, it will become plus 1. When 2 multiplied by x moves to right hand side, it will become x equal to 1 by 2. So, x equal to 3 by 2 and x equal to 1 by 2 are the solutions of the equation. The roots of the quadratic equation are 1 by 2 and 3 by 2. Nature of roots. Nature of roots refers to the types of solutions that a quadratic equation can have based on the discriminant. The discriminant is a term within the quadratic formula that helps determine the number and types of roots. Discriminant delta is equal to b square minus 4ac. The equation ax square plus bx plus c equal to 0 are given by is equal to minus b plus or minus under root delta by 2a. Because where b square minus 4ac is equal to delta, we are substituting it in that formula. Case 1. If delta greater than 0, we get two distinct real roots, that is x equal to minus b plus under root b square minus 4ac by 2a and minus b of minus under root b square minus 4ac by 2a. Case 2. If delta is equal to 0, then we get two equal real roots, that is x equal to minus b by 2a plus or minus 0, x equal to minus b by 2a and minus b by 2a. So, the roots of the equation ax square plus bx plus c equal to 0 are both minus b by 2a. Case 3. If delta is less than 0, then there are no real roots. Therefore, there are no real roots for the given quadratic equation in this case. Let us look into the three cases. A quadratic equation ax square plus bx plus c equal to 0 has two distinct real roots if b square minus 4ac is greater than 0. It has two equal real roots if b square minus 4ac is equal to 0. It has no real roots if b square minus 4ac is less than 0. Let us look some examples to understand about the roots. Example: find the discriminant of the quadratic equation 3x square minus 10x plus 3 equal to 0 and hence find the nature of its roots. Solution: the given equation is of the form ax square plus bx plus c equal to 0. Where a equal to 3, b equal to minus 10, and c equal to 3. To find the nature of the roots of the given quadratic equation, substitute the a, b and c values in the discriminant formula. Therefore, the discriminant delta is equal to b square minus 4ac. In place of b, substitute minus 10, that is minus 10 whole square minus 4 into 3 into 3. Ten square, that is equal to 100. Minus into minus, it gives us to plus. Hundred minus 36. If we subtract 36 from 100, we will get 64, which is greater than 0. Two distinct real roots if b square minus 4ac is greater than 0. So, the given equation has two distinct real roots. Let us see another example. Find the discriminant of the quadratic equation 2x square minus 4x plus 2 equal to 0. Find the nature of its roots. Solution: given. The given equation is of the form ax square plus bx plus c equal to 0. Where a equal to 2, b equal to minus 4, and c equal to 2. To find the nature of the roots of the given quadratic equation, substitute the a, b, c values in the discriminant formula. Therefore, the discriminant delta is equal to b square minus 4ac. Now, substitute the a, b, c values in the given formula. B equal to minus 4, minus in 4ac substitute the a and c values, that is equal to 4 into 2 into 2. Now minus 4 whole square is equal to 16. By multiplying 4 into 2 into 2, we get 16. When we subtract 16 and 16, we remain with 0. We know that we get two equal real roots if b square minus 4ac is equal to 0. Hence, the given quadratic equation has two equal real roots. Points to remember. A quadratic equation in the variable x is of the form ax square plus bx plus c equal to 0, where a, b, c are real numbers and a not equal to 0. A real number alpha is said to be a root of the quadratic equation ax square plus bx plus c equal to 0 if a alpha square plus b alpha plus c is equal to 0. The zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same. If we can factorize ax square plus bx plus c where a not equal to 0 into a product of two linear factors, then the roots of the quadratic equation ax square plus bx plus c is equal to 0 can be found by equating each factor to 0. Quadratic formula. The roots of a quadratic equation ax square plus bx plus c is equal to 0 are given by x equal to minus b plus or minus under root b square minus 4ac by 2a, provided b square minus 4ac greater than or equal to 0. Quadratic equation ax square plus bx plus c is equal to 0 has two distinct real roots if b square minus 4ac is greater than 0. It has two equal real roots, that is coincident roots, if b square minus 4ac is equal to 0, and it has no real roots if b square minus 4ac is less than 0. Thanks for watching.